So thanks everyone for attending the second webinar for the open source software series from the Near Surface Geophysics Society of Explorational Geophysics Technical Subcommittee. This is the second webinar on Python, where we're going to be discussing sort of the basics of Python, the programming language. This is a continuation of the first one. So in the first one, we sort of went over what is Python and how to use it in terms of setting up your computing environment and different ways of working with it. And then we started to go into some more, actually how to program in Python in terms of syntax and data and stuff. So today we will be starting with Joshua, continuing on talking about data types. Josh, do you want to unmute yourself and maybe give yourself a little introduction and then get started?
Okay, that's fine. Yeah, I think I just go ahead to share my screen. And
also just a reminder for everyone who has joined us, if you have any comments, something you can't see, something you can't hear, feel free to throw it in the chat. If you have any questions, please use the Q&A feature that we have at the bottom there, and we'll be trying to get through all of them as we go through the presentations. We'll have some time at the end to kind of wrap up everything. So thank you.
Yeah, good evening, good morning, depending on your location, good afternoon. So we'll be continuing from where we stopped the last time, and we'll actually be doing it a bit faster, but I think the last time we shared this particular Jupyter notebook to everybody. So I believe either most of the participants joining today, or if you're joining us for the first time, probably you have the Python Anaconda already installed in your system. If not, you can go ahead to just look for, use the Google Colab online and use the Python Jupyter notebook and just open it, and you have everything we're doing today. And then probably Chris, for those that probably wouldn't have it, you can still share the Google Drive link probably on the chat for them, and so that they can have access to this particular Jupyter notebook. So the last time we looked at basic syntax, and we looked at some keywords and identifiers down, I think, to making comments in Python. So today we'll just go ahead to look at different data types. We'll look at simple operators that we do basically in Python. So starting with operators, basically mathematics, which is just the basic things we learn from the primary school level. It's addition, subtraction, multiplication, division, the modulo, exponentiation, and divides around down to the nearest integer. So basically it's just the normal operation you do, adding few things. Probably you have for example, we are adding 1 plus 1, just normal addition, the way you do with your pen and paper, or you're using a calculator. So the Python just returns this, and it obeys the rule of the BODMAS that we already know, looking at which operation should come first and which should come later. So if I make an example, 1 plus 1 times 20 divide by or minus, let's say 5, what we should have, we should be having 16. So this tends to be, it multiplies 1 times 20 to give you 21, and then it adds up. The next operation is to add it up to plus 1, which gives you 22, and then 1 times 20, 20. Adds 1, it becomes 21, and 21 minus 5, you have 16. And then which you can go ahead to look at different operations. You can use the division sign here, the multiplication sign is here, the addition sign is all here. So just basic things that you used to do normally for all operations in mathematics that you do. If you're multiplying 10 times 40, you have the value of 40. If you're dividing 10 divided by 4, you have 2.5 being returned back to you, as the case may be. So all this, you could practice more and more. I'm going to move very fast because we have a lot to look at for. Now we'll look at, we looked at variables and the previous time. Now for the variables, it's all about trying to assign a particular number to a particular variable. For example, what you're trying to do here, I have a variable called A, I assign it to a particular value called 20. And when you call it, it becomes A equal to 20. And whenever you call A, it's been stored in the memory. It gives you exactly 20, or you try to print the value of A, it returns back 20 to you. So if I redefine the value of A, it takes the most recent value of A. For example, within this particular cell 66, I define A as a variable equal to 20, and then I printed it as this, and I define another A here, and I give it another value 15. Now this time around, it's not going to call this same value 20, but it calls the next A equal to 15, because that is what you redefine. So if you're defining it based on different variables, so you probably need to look at your naming convention to be sure that you are using different naming convention to assign different values to whatsoever variable you have. For example, if I don't want to retain this, I'll probably change it to be a B, so that I'll know that I'm actually dealing with a different variable. Now with that, I try to put examples here for us, where you can assign either an integer here, or you assign a floating number. Now, the difference between integer and floating is basically, now an integer is where you have the numbers without the decimal places attached to it. For example, we have counter here, we assign it to be 100. Miles here, we said it's 1000.0. And then you can assign a variable with strings as well, called, like, for example, here, join. And whenever we print this particular cell, what we see, it's printing counter here as 100. It prints miles here as 1000.0 as a floating point number. And then we have printing name here as a string called the name John here. So we can do multiple assignments. Here, for example, what we mean by multiple assignment is we could assign the value of 1 to the variable A, B, C, all equal to 1. Or you're trying to say the value of A should be the same as B, and the value of B should be the same as C, and the value of C should be the same as 1. So hence, if C equal to 1, automatically B becomes equal to 1, and then A also becomes 1. So that's what we are doing on this particular line here. Sorry, what I'll do briefly is to put light numbers so that I can be making a reference here. And then at the same time, you could do a kind of multiple assignment. Instead of writing A equal to 1, B equal to 2, and then C equal to a string called John. Now, what we just did here is just to combine everything and put it into one line instead of writing into 3 different lines here. So this expression here, I take it out, I create a new cell and put it here and call it, and print. I put them here, down here, and call them fluid. So it gives us the values A, B, C, 1, 2, and John as a string. Now, it's the same thing that we are just doing right below here by separating it, but just putting it on one line. It still gives you the same answers you can see in this particular output within here. So the next, I will take probably 2 minutes to give an exercise, and I will need a fast response from people attending. Just briefly look at what we have on this cell. I need to see response from people to see if people can have in the result. Now we have a variable called reservoir volume, which is this particular value. We have rainfall called 5×10⁶ exponential 6. Now the question here is the current volume of a water reservoir, it's equal to this. Then the amount of the rainfall from a storm, it's equal to this. Now, the question is, I need answers to this. I'll pause just for 1-2 minutes and see if we begin to have response from people. Just decrease the rainfall variable by 10% to account for what we call runoff. So you need to write a new line here by decreasing rainfall here by 10% to account for runoff here. And then you add another line here, said add the rainfall variable to reservoir volume. So the answer you have on this line, you're going to add it to whatever you have to have what we call the new reservoir volume. So Chris, Noah, let me know if we begin to have response to the answers. I will just wait just 1 minute while I wait for a response. Do we have response already?
So far, nothing yet. So folks who are joining us, the purpose of this, if you can have whatever, method you're using to run Python open, just to do a quick, the quick calculation here of just trying to decrease the rainfall variable by 10%. Obviously, you could also do that in a calculator, but point here is kind of to give some practice to see, of just running a fairly straightforward operation. So if people have any questions on how to do that, we can go over that. But just want to see if we can get something from that first. People can give it a shot on their own.
Is there any response yet?
None so far.
So this is basically what we requested for just to save our time. The volume of the reservoir is this particular value here we have, but the rainfall here it's this. So the runoff is just 10% of the rainfall. So which means if we're accounting for runoff as 10%, the rainfall total would actually be 90% of the rainfall when you take the 10% out of it. So add that variable to the reservoir volume. So all we're doing is the new results we have called rainfall runoff here plus the reservoir volume will give you the total new reservoir information. So when you do this and you click on, you try to print your reservoir information, let's see the value we have. Now we have a new value, which is 449,000,000 as the case may be, I think to the power of 1, 2, 3, 4, 5, 6, 7, 8. So 4.49 to the power of 8. That's the new volume, reservoir volume that we have. So we can look at other operators. Normally you have in maths, you have less than, you have greater than, you have less than or equal to, you have greater than or equal to, you have equal to, and then you have not equal to here. So I try to make a particular table here which can help us in understanding. For example, if I said 5 is less than 3, now what I would have been returned to me, because I know 5 is actually greater than 3. So I have a Boolean expression being returned to me. Now, when we talk about Boolean expression, either it comes in true or it comes as false. So we know that 5 is actually greater than 3. So we have this, the Boolean expression returned to us as called what? As false. Now you can try that by clicking 5 is less than 3 and see the answer. Now what Python returns for you is returning to you that it's actually false. But what if we change this to greater than sign? What we see is that it's actually true. So you have the response or the output coming out as a Boolean, either false or true, based on these particular operators that compare one or two things together. Now, the next things we look at for is logical operators. We have three logical operators. We have and, we have or, and we have not. So for when you're considering and you're comparing two things together. So for example, we're combining 5 is less than 3 and 5 is equal to 5. Now, the response here, our output will be false. Reason being the fact that for when you use and, there's what we call the truth table. I will enjoy it. You can Google truth table as an extra material for you to understand everything that has to do with the logical operators and, or, and not. So you can go ahead to Google this. I think it's just a takeaway for us. Now we have 5 less than 3 and 5 equal to this. Now we have this returning as false. Now we check it in the new cell. We see that this is returning to us as false. Now, reason being the fact that when we have and only becomes true when the two information that you're comparing are actually true. So, but when one of it is not true, you always have a false. And so when you look at and Google truth table, you have different expression. When you combine a false information and a truth information, you're looking at the logical operator and what happens. So when you look at it, you have more details with what I'm trying to show here. Now, and the next is or 5 less than 3 or 5 equal to 3. Now, I wrote a statement here. It evaluates if at least one of the statement is true. So when you're looking at an expression with or, now whenever one of the expression is true, it returns the value true to you. So for example, we can take this, run it into in a new cell and see what the results will be. We'll always have true. But what happens if we have both statements to be true? It still returns true to you. But what happens if both statements are false? Let's say 5 not equal to this. We have false being returned to us. So when you check the truth table for each of these expressions, the logical operators, you have more details on what we are trying to say here. Now, for example, I have an example written here where we kind of have a multiple line variable assignment here where we have SF population, comma, SF area, where we assign these particular values to them. We have a population in Rio, and then we have the total land area in Rio to be as this. Now, we said San Francisco population density, which is normally the total number of population over the total land area, where we have SF population over SF area. So the details here accounts for information within San Francisco, while the second line accounts for information from Rio de Janeiro. So when we said what you're trying to do is you're calculating the population density and you combine this by this, you already will be having an output for what you're having up here. Now, I put up a short assignment here for us to do, an exercise for us to do. Write the code that prints true if San Francisco is denser than Rio and false otherwise. Now, what we're trying to say is compare the population density in San Francisco and the population density results you get from Rio de Janeiro. And then all you need to do is check if it's one is greater than the other or not. So all you need to do is use one of the operators, San Francisco population greater than Rio de Janeiro. So what will be our answer? Our answer is false, which means that if we take this particular value into a new cell to actually see the values of what we're going to get, I take this into another new cell. I run this cell and I run this cell. I call this variable, and we call this. Now I have a value of 13,729, and I have a value of 13,265 here. Now, actually, it's true, San Francisco is not greater than Rio de Janeiro. And so Python returns to you that the answer is going to be false. Now, when we look at data types, we have different, we have numerics, we have text styles, which numerical data will come either as integers, like I highlighted, either will come as float or it will come as complex numbers. I think I made certain examples here where you can have, when we say integer, like I explained earlier, you just have whole numbers, 1, 2, 3, 4, 5 without the decimal places. And when we say it's float, we have it been with addition of the decimal places, 20.5, 20.2, 20.3 as the case may be. And then when we have complex numbers where we have both alphanumerics being combined to give you a complex number. And then you can look at text types. They normally comes as strings. And when it's coming as string, all you're trying to express here as strings is you use, put up examples here for us. You use either, I think we did that in the first session, where we have both either a double column, the double apostrophe, or we have, double quotation, single quotation, or you're using a triple quotation for when you're considering strings. And then we have sequence types, which comes in as list, as tuple, dictionary, sets. We're going to look at that now in detail. I think I'm going to jump to this to go fully into data structure. Now we're looking at the different data structures and data types that we're going to deal with. We'll look at lists, we'll look at tuples, and we'll look at dictionaries, and we'll look at sets in this case. Now the difference between when you're writing a list, it normally comes with the square bracket, this particular bracket here. Now, while when you're writing a tuple, it comes with the normal brackets that we have. Where you're dealing with a dictionary or you're dealing with sets, it comes with the curly bracket. These are just conventional things we know generally in mathematics. So now, for example, the content of a list, I take example here, I put it in a new cell. You can write either a list can contain either numbers or it can contain text, and the text you ensure that you write the text as strings. It's very important to note this, and the numbers could be integers, the numbers could also be floating numbers, as we can see. So if I have a particular list here called SCG list, and I call it, it still calls back this, and then it kind of writes the output for me, 1, 2, 3, and then example this. Now I added several operations here. How many minutes do I have, Chris, to know?
Probably just do another 5 minutes or so, just so we can do the other two.
So there are several operations you can do, and how you can manipulate with a list. Either you're combining one list to another list, or you're trying to delete a particular item from a list, or you're trying to add a particular item from a list, or you're trying to remove the entire items that are within the list and all. So I made a kind of list, a kind of line of operations here that typically we can use. And I will leave that to us, but I will explain each of it very briefly so that I can be able to cover all the things. Now, for example, here we have a list called 1, 2, 3 SCG list. If I want to, I have a new list that I want to append. Whenever we use the word append, that is you're trying to add 55, 55, and 12 into this particular list, SCG list. So if what we're trying to do is we take out this into a new cell, for example, and we're trying to append this into this particular list above, what we'll be having is, it will add up this as a single element into the previous list that you wanted to attend. So whenever you use the function append, but if you want to add it as a different, into as different elements, you go ahead to use the word extend the list. So if you use extending this particular list above, what it does for you automatically is it adds each of the elements as different elements, unlike what we have seen using the word append here, which adds it as looking at it as only a single element that has been added to the particular set. So when you're looking at the index in this case here, this is 0, 1, 2, 3. So it looks at this as 3, but in this case, when you extend, it looks 0, 1, 2, 3, 4, and 5. So it's important. I will look at a few things about index as we move ahead. And then you could remove an item from the list by using the keyword remove. SCG.remove example, it removes example from this particular list above here. You could pop out the value of 1, the first index here, call this, and it will take out this. You could use the keyword clear, and it will remove everything from the list and make it quite empty. Now, it's important to note that lists are mutable. That's why you can actually either remove, add, or delete everything, which is different from a tuple. A tuple is immutable, so which means you cannot change what is actually inside the bracket within the tuple. Now, secondly, we have a lot of exercises below here you could actually practice more, which I've actually added to it. You have sorting here. You could see sorting here, I think this. Here you have sorting where you could reverse like a list here. You could start from the highest to the lowest, or when you say, oh, the reverse is false, it still maintains what you have. You could look at the index. For example, if we're looking at index, we're actually looking at the positions at which each of the elements within the list are occupying. For example, like I said, 1 is occupying, index normally starts from 0. So 1 is occupying 0, 2 is occupying 1, 3 is occupying 2, 10 is occupying the 3rd position, 30 is occupying the 4th index, and 10 is occupying the 5th index. Now, we look at tuples. Tuples are the same as lists, with the exception that the data once entered into the tuple cannot be changed. It's immutable. So looking at, for example, what we mean by the immutability of a tuple, for example, is, I will come here. Sorry. So we have a tuple called 1, 2, 3 within this bracket here. And then I'm trying to probably change what is inside the bracket. So I want to remove 1 that is within this particular bracket here. So if I probably try that using a keyword, the same way we did with my tuple, let's say X, we're calling in a new one, let's say equal to my tuple, but remove. Let's say remove one. Now you have an error, you have an attribute error trying to tell you that sorry, a tuple object has no attribute called remove. Now I think I made a few examples below here where you could see whether you could change what is inside and what is not inside. For example, I put a difference between the tuple and the list here, where we have a list here. We can list, we want to replace 3. Can you see this? The index 3 here. So the index 3 here, we're trying to replace 0, 1, 2, 3. That's we're trying to replace 4 with the value of, let's say, I put this as 5 because we have 5 here. So if you try that, you could see that the index 3, where 4 is now replaced by the number 5 because we try to replace it at this point. But if we try that with a tuple, it becomes impossible. We said, okay, we want to replace 5 here with 8. So I put 8 here now, but if you're replacing 5, you're going to call the index location, which is 0, 1, 2, 3, 4. That's why we're having 4 here. And if we're calling in and trying to replace it with 8, let's see what Python gives to us. Now Python says tuple object does not support item assignment. So this gives this basic difference between the two, that list is mutable and tuples are immutable. Now we look at dictionary. Dictionary is just a typical example, like when you have, it gives you kind of like a key value pairs. For example, you have a bag. The handle of the bag is the key that holds that particular bag you're actually working with. So for every dictionary you're trying to create, we have this key value pairs pair that is the one here. You see, we attach a value called Python to it. This is the key, and this is the value. This is the key, and this is the value for this particular dictionary. So always remember, dictionary are used to store kind of like a key value pairs, where you typically can say, okay, I'm trying to assign, I'm trying to create a new dictionary where I have a scenario where I would say I have SCG exams that I did, and probably, let's say I scored 70 marks in it. I can put the value like that. I tried to put another, let's say another key here. I say, okay, I have another stove. We call it to be this, and let's see if it goes through. Now, SCG exams is not defined. So always take note. This, we try to make it as a string and see if it goes through. SCG school not defined. Make this as a string and call it again. So we have a new dictionary where it defines XCG exam 70 and SCG SCH as what? As Java. Probably let's just put a number to be a bit consistent. Let's say 80 here. So a bit consistent where, so take note, your key can either come in as a number, it can come in as a string as well. And then depending on the value you want to attach, the values can be integers, it can be it can be strings here, and as the case may be. So we have several practice, a lot of things here put here you can practice. You could pop out, you could pop out items, you could clear what is inside the dictionary. The get function here tries to access into the dictionary to get a particular, when you're trying to do a get function here, you call the key, and then it returns back the value as an output for you. When you call the second key here, it returns back the output Java as the output for you. So whenever you call a key within a dictionary, you should expect the result should be the value that will be you will see as the output. So then for sets here, which are normal typical way, we in mathematics where we have different operations in sets. You remember you have it could be union, it could be intersection, and so on that you have normally in set operation. And like I said, in set is also represented as with curly bracket, the same as what we can see in dictionaries here, represented with curly brackets. Now, we could add elements within the cell set, we could remove. Now, I want to show you a typical difference between set and dictionaries. Now, you will see that in set, when you're printing out the output, now items that are repeated within the set, within the curly brackets, in the output, it only takes one of it and reports it back to you. For example, we have 5 here. We have multiple number of 5, almost 3 of them. But then when we printed the value of the set, what we have, it reports 1, 2, 3, 4, 5. So whenever you have unique values, it just take one of it and report it back as part of the output that you're going to add. So you could add a number to the set, like for example, I have a set here with 1, 2, 3. I can add 4 to this to have a new set which have the value 4 included in it. For example, you could see the results what we have here, where we added this 4 into this. So sets are also mutable. You could add things, you could remove things within the curly brackets. So we have a lot of examples here that you could do. I spoke about the standard operations that we see in normal sets. You talk about union, where you compare 2 sets, and then you look at what is, you combine set 1, set 2. For example, I take this. I have what we call the first set here it has 1, 2, 3, 4, 5, 7. My set 2 has 3, 4, 5, 6, 7, 8. And then I create a union. That means it combines the set here and the other values in the other sets together. And what it returns to you is we have 1, 2, 3, where we have repetitive or similar objects between the 2 sets. It just reports one of it. So we can see that 3 is similar, common here, and 3 is common here. So we have 1 reported to us. 4 is common, 4 is common, it reports 1 of it. 5 here, it's not common, so we have 5, we have 6, we have 7, and 8. So take notes, just basic things that we do in mathematics. You could do intersection. Intersection looks for all values that are key. For example, we can take this, and I print it here as the intersection of the values above. It looks for the items that are similar in both cells and return it to you. For example, 3 and 4 here are common for the both, and then we have this reported to us. So take notes, you could write either union, or you could use this the line on your keyboard. Sorry, I think I've forgotten the name of this. You could use it as a value when you're using that as your union. You could use and as for intersection. When you're finding the difference between two sets, you could use the negative sign. When you're trying to look for the symmetric difference, you could use this particular sign. You, like I said, sets are mutable. You could clear, you could add, you could do everything that you can do with the sets. So I think I need to stop here so that we can continue with other parts. I put in some links here where you can find extra materials that you can study more with it. Thank you very much.
Awesome. Thanks so much for all that, Josh. I think I don't see any open questions in the Q&A. So I think since I'm kind of pushing for time, Noah, do you want to just jump into yours and then we'll just, I guess, take a slew of questions at the end?
Yes, sounds good. Cool. Yeah, thanks, Chris. So Josh already went over sort of some of these logical operators: equals, greater than or equals, less than or equals, less than and greater than, as well as, he briefly touched on the Boolean operators. So I'm just going to go over the Boolean ones really quickly. Basically, what they are doing is just reversing the truth of this first statement. So integer 1 and 3 are 1 and 2, so they're not equal to each other. So this statement by itself, if you were to evaluate it, it evaluates to true because they're not equal. But then this not, when it's added here, turns that true into a false. So that's what the not operator does. And you can see here that this will print false because this is a true statement, and then it gets flipped. The second one, not true, evaluates to false. And then this last statement, not false, evaluates to true. So not just flips the statement that it's applied to from true to false or false to true. The and operator, it needs both statements to evaluate to true or it to evaluate to true. So here, this statement is true because these two integers are not equal to each other. This statement is also true because these two integers are equal to each other. And so if you evaluate this statement, it says true. Because the and statement needs both statements to evaluate to true, this true and false is going to evaluate to false because only one of these statements is true. And then finally, true and true evaluates to true. You can also link this with even more operators. So you could say true and true and true. And so this means that all of the statements need to be true for this to work. So the single false means that none of this works. Or the way or works is that only one of the statements needs to be true. So in this case, int1 is not equal to integer 3. Or integer, right, so this statement evaluates to true. This statement evaluates to false because they are not equal. But because the or is applied, the overall result is that this statement is true. And we can see here, true or false evaluates to true. And then false or false evaluates to false. And just like with and, we can use or to link a bunch of statements. We say false or false or false or true. In this case, it evaluates to true because there is one true statement in this chain of operators that it's checking. So the next thing I'm going to talk about are if statements and then while and for loops. These are very common sort of core things that you will use a lot in Python, basically, if you're writing any code. If statements are pretty simple, it just checks whatever is given after the if and then before the next line. And if it's true, if this statement evaluates to true, then it will do whatever is in here. So in this case, this statement evaluates to true. So it prints this line. And then this is just all. Just gonna move this so that it doesn't print it like that. So it prints this statement because the two integers are equal. So this statement evaluates to true. And you can see if I change this to if true, it prints it. If I put false, it does not. And then again, if I add a not, it flips this. And then, so you can use any combination of the same logical operators from above in here, as well as the ones from before, the less than or equal than and everything. And you can chain them. So you could say if false or true, and it will print it because there's one true, so this does evaluate to true. This is kind of just further showing that if false, if true. This does not print because the statement with the if evaluates to false, and then this one does print. So you can also have the next thing that goes along with if are else statements. And so this is something that gets evaluated if the statement provided to if evaluates to false. So in this case, integer 1 and 2 are equal. So this statement evaluates to false. So this does not get executed. And then what else does, it means if this doesn't happen, this will always happen. And so if I run this, you see that this print statement gets printed. The other thing you can have is additional if statements called if else. And this is the syntax for it. It's ELIF. And so basically what this does is it first checks this statement. And if this is not true, then it goes on to check the next statement. And so we see that this does not get printed, and then this does get printed. You can also nest if statements. And so here, there is a first if statement that gets evaluated. This is true. So then it moves inside the first if statement, evaluates this other if statement, which is also true because integer 4 is, I think, 100. You need to have something inside your if statement. You can't have an empty if statement. So pass, if for some reason you need to have an if statement with nothing in there, you can just put it in pass. So it evaluates to true, this evaluates to true, and then this doesn't do anything because pass just tells it to keep moving. But if you remove the pass, it complains. While statements will run until the condition that they started with changes. So in this case, I'm setting this variable run to true, some variable count to 0, and then I say while run, and this is just going to print the current count, increase the count, and then when the count is greater than 10, it's going to set run to false, which will stop the while loop. You can also, with while and for loops, put an else statement after them that runs once the loop is finished. So this just counts from 0, and then when it gets to 10, it sets run to false, and so it doesn't keep going. Something that you can use with both while and for loops, which I'll talk about next, are break statements. And so one of the things with while loops is that they won't stop running as long as the statement is true. And so here what I've done is I've changed it so the count gets increased by 3 each time. And then this is only checking if the count is equal to 10, and then it sets run to false. So this statement will not stop running, and you see that it kind of just keeps running forever. So I have to manually stop it. So what I'm going to do is uncomment this other thing that says if the count is greater than 100, and that just stops the execution of the loop. And you see now it stops at 99. So if you're using while statements, it's good practice to have something in them to stop the loop if it's run for many more iterations than you planned, just because whatever code or logic you're using to stop the while loop could, get missed or messed up. And so having some sort of stopgap so the loop just doesn't run, so the while statement doesn't just run forever is good practice. Continue, what that does is it just skips the rest of the loop. And so what we see here is pretty much the same while loop as before, but now if the count is greater than 5, it continues. So it doesn't run the rest of this that's inside the while loop. And something I should have said before is that the way Python sort of determines what's inside or outside of these if statements or while or for loops or everything is the indentation. So if I were to take this while loop with continue that I was about to demonstrate and remove the indent, it complains because it expects an indented block after this while loop. And so if I only indent this, then the only thing that's going to get run inside the while loop is that. So Python sort of sees this while loop as extending to as far as this indented block goes. So I'm going to indent this stuff again, so it sees it as inside the while loop again. And so if I run this, because it's continuing once the count is greater than 5, it's not going to run this, so it's never going to set the condition to false. And so you see again that it just runs forever and I have to stop it. If I comment this out, now when I run this, it stops again as it should. For loops are similar to while loops, but instead of running until the condition is set to false, they run for a set number of things. A very common way to use for loops is with this default Python function called range. And so what range does, if I say range of 10, well, first, if I say range of 10, it just says, okay, it goes from 0 to 10. If I turn this into a list by wrapping the list constructor around it, now I can see what the range actually produces. So it starts counting at 0 and increases by 1, but it doesn't include the last number in the range. You can also, the default is that it takes a step size of 1, but if you put another variable into range, and this is a very basic Python function, we'll go over functions in a second, then you see that instead of stepping by 1, it returns something that steps by 10. So what this loop does is iterates through whatever this is, and this variable index becomes equal to each item in here. And so if I run this, right, this is just printing the two different types of ranges. If I run this, because range 10 starts at 0 and then steps up by 1 until 9, because it doesn't include the last number. If I print this, this variable index becomes equal to each of those numbers one at a time, one after each other. For loops also work with lists that don't have numbers, but it will work with really anything that it can iterate through. And so if I, instead of a range or a list or something, if I just give it a number, say 10, it says int object is not iterable. Strings are iterable though. So if I give it a string, it will just iterate through where index becomes equal to each of the characters in the string. But this works with lists of any arbitrary objects. And so here it just prints the different items from in the list. You can also iterate through multiple things at once using this default function, Python function called zip, which basically just pairs these lists. And so if I print this, you see that item becomes equal to each item one at a time in color list. And then integer becomes equal to each integer one at a time in the integer list, which goes from 0 to 3. So this is basically how for loops work. You can also nest for loops. And so what this looks like is I have this list of integers, and this first loop, number becomes equal to each integer one at a time. And then in this second loop, it just counts up from 0 to that number, printing the number one at a time. And so if I print this, first it says counting from 0 to 4, and then the second for loop within that prints the numbers between 0 and then and because I added 1 to the number here, it prints all the way up to the actual number. Whereas if I remove this, because of the way range works, it would just count to one number below it. And it does this for every number in that list. So that's if statements, for loops, and while functions. And then finally, I'll just go over what functions are in Python. And so these things I already used, range, 10, this is a function that is just a default function within Python. So zip and list, when you use list, it's kind of a function. It's using a constructor that's associated with that class. So I'm just going to go over this pretty quickly because we're running a little bit late on time. But basically, you use def and then the function name and then whatever you want to be input. And so this function is very simple. All it does is it just returns, which is the output of the function, the result of evaluating this statement. So int1 and int2 are 1 and 1, so they're equal to each other. So first I define this function here. And if you just define the function, it doesn't do anything because you actually have to call the function. And so now I can use this name that I've defined and pass these two integers, and it prints the result, and the result is true. If I give it not the right number of input parameters, then it's going to complain that it's missing an input. So here I gave it an integer and a floating to different data types, and it's going to try and compare them anyways. So one of the things that's pretty common to do with functions is to add data validation. So within this function here, I've now added this if statement that is just checking the type of the two input things. And so now when I call this, redefined function, and because I previously defined the function and then defined it again, this new definition overrides the previous one. So now it has this additional if statement in there. And so when I call it with an integer and a float, it prints this statement and then still tries to evaluate them. And obviously you can, go further with this where you check for strings or all sorts of things. Functions can obviously be extremely complicated, or they can even call themselves. So the classic example of this is a function used to calculate the factorial value of a number. And so the factorial is you just take a number, multiply it by 1 minus itself and you keep doing this until you get to 1. And so all this function does is it takes the number. If the number is equal to 1, it returns it. If not, it returns the number times itself. It calls on itself minus 1. And so what this does, so if we call it for 1, the factorial of 1 is just 1. Factorial of 2 is 2. 3 is 6, and so on and so forth. So you can also have functions that call any sort of number of other functions. Functions, they can be arbitrarily complicated and call whatever you would like. Then another important thing for functions is that you can have default parameter values. So in this case, I've written this little function called power function, and it just raises a number that you put in to a power. And if you don't give it a power, it just assumes the power is 2. And so here, if I just call power function with just the 1 input for 2, it raises it to 2. which is 4, 3, raised to the 2, which is 9. But I can also give it a power if I want to use a power other than 2. So here I'm giving it a power of 3. And so now it's 3 raised to the 3, which is 27. There's also some input validation here. So if I put in a string for the power, it won't run it because it tells me why, as opposed to just trying to do something that's wrong. And the same is true for the input number. One final thing I'll go over really quickly is list comprehension, which is sort of a very convenient way to do some for loops. So if I had these two lists and I wanted to multiply them together, one thing I could do is I could write, I could make another list. I could write this little for loop that iterates through the items in the lists, multiplies them together, and appends them to this. And so if I run this, you see that the result is, 2 is 2 times 1, 6 is 3 times 2, 8 is 2 times 4. So another thing I can do rather than writing this for loop is I can do this all in one line by putting square brackets. And then basically it's a for loop, but all just in this one line. And so this is what it's doing to make each element in the list. And then for X and Y in these two lists. So X becomes equal to each item in list 1, one at a time. Y becomes equal to each item in list 2, one at a time. And then the resulting list, its entries are filled with X times Y. And so if I run this, I get the same thing as above. So list comprehensions, again, can be arbitrarily complicated. You can put other, you can have additional logical if statements in here. So this is if X is not equal to 2. And so now the first one where X is equal to 2, it skips that. So that does not end up in the output list. And you can, use ors and nots and everything else as usual in these list comprehensions. So this is a handy way to make lists and manipulate lists. I'm going to stop there. And have you take questions from this or from Joshua's section for a bit, and then we'll move on to the final presentation from Chris.
Just bring us into the last topic that we're going to discuss here, which is in using data visualization within Python. Real quick, the link that I dropped in the chat there will take you to this shared Google Doc that has, or shared Google Drive that has all of the example codes, presentations, whatnot, from both our first Python workshop and this one. That link will also be sent out in an email sent by SEG after this event ends, which will also have a link to the, we can also send out a link to the SEG YouTube channel that has a playlist where all of our open source software recordings are. So keep an eye out for that. In the meantime, let's talk about a little bit of data visualization. Let's see. Okay, cool. So everyone's seeing the right thing for this, right? Not seeing the actual presenter view. Yeah, cool. All right. So this won't take too long. When it comes to visualizing data within Python, because obviously, manipulating data is just one part of the process, right? Being able to present data and make it, look intuitive and readable to your audience, depending on whether you're putting in a paper or a talk or a poster. That's half of the battle when it comes to scientific communication, right? So when it comes to visualizing data within Python, there are two very common packages that end up being used. The first is called matplotlib. It's very just basic visualization, can handle 2D and 3D plots. It spits out just the most generic looking plots you've ever seen, unless you put in any additional lines of code to try and format stuff. But it's very well integrated with a lot of the main numerical packages that Python uses, particularly NumPy and Pandas. I think if we're, one future workshop will be all about using NumPy and Pandas for data manipulation and database structures. So that'll be coming at some point. But so we have Matplotlib, and then we also have Seaborn, which is kind of more like an extension of Matplotlib, where a lot of it is still based in the same syntax and the same code that Matplotlib uses, but is designed to kind of be more straightforward. It's really designed to have you just type in one line of code, and then here's your plot with a lot of the formatting already taken care of. Typically, it tends to be used more or it specializes in statistical data, but can be used for any type of data visualization. First, we're going to delve into a little bit of detail about Matplotlib, some pros and cons. So there's a lot of customizability in the plots you can use here. The aspect ratio, the specific sizes of the axis labels and the title and your color bar, like everything has a way to fine tune the size and conditions of it. It has a very similar syntax to plotting in MATLAB. So if you're already a little bit familiar with MATLAB and the way that you generate plots there, it's not too much of a leap to start plotting with Matplotlib. Since it's very commonly used, there are a wide variety of public help sites and forums that you can type in any question you have. If you're trying to work on some code for plotting something and you get this weird error, you can, almost absolutely just copy and paste that into Google, and there'll be 5,000 Stack Overflow forums of people with the same problem, but with different unique solutions to them. Additionally, if you're trying to create a series of plots, Matplotlib is able to kind of create and open more and keep them open without trying to push all them through at the same time, which we'll see that Seaborn does. And so tends to be able to open and deal with a large number of plots without significant memory issues. Anytime you start kind of overusing and pushing Python in your computer to past a certain point, it basically just throws out an error. It says like end of memory, and it says like, you've used all my resources, I can't do anything else, we're shutting down. It takes a little bit longer for Matplotlib to get there than Seaborn, but we'll get into that in a little bit. As far as cons go, if you're not too familiar with MATLAB's plotting syntax, it can be a little bit unintuitive to kind of start getting into the rhythm of what you want to call when you're trying to specify a specific detail in your plot. Additionally, it is developed for very basic plotting. So if you wanted to try and make some very, for some very beautiful and very intuitive and well-crafted plots, you're going to need there's a little bit of a learning curve, a little bit of extra work that has to go into actually making it look pretty decent. So just kind of highlighting a few features here. I have an example code above this GIF to the left here, where you can see that you specify your title font size, the size of your axis ticks, the size of your axes labels, and then with Matplotlib, you essentially just call what aspects of your plot you want to be working on, you want to be editing at a time. So they'll have for some things you'll see that they have like fig, ax equals whatever, showing that you can specify the details and characteristics of your figure as well as axis characteristics at the same time. And you see it's quite a few lines of code just to get everything to look readable like this. These were figures I was using in a talk, so I wanted everything to be pretty large in size. I wanted it to be readable. And I have all of this compiled into a for loop, like Noah was talking about, where it's basically running through this data set and it's creating an image, a distribution of calculated bulk conductivity values at each time step. So it was able to do this without having to shut down because of lack of effective usable memory. So it is quite efficient in trying to get everything out there and trying to create a whole bunch of plots at once. It's also very easy to set up and configure. If you want to have a 3x3 box of different individual subplots in one go. There's a little example code here that's from the matplotlib API site. It just gives an example of, do you set up your grid? How many rows of figures do you want? How many columns? And then you get to specify unique characteristics for each one with pretty little or pretty few lines of code. If in the Google Drive link that I shared, there's an example code in there to kind of run you through importing some data, plotting it in matplotlib, and then plotting it in Seaborn. This is just this matplotlib snippet of that. All it's doing is just, we have this distribution of bulk resistivity values. We were trying to see how they all look, see how they're spatially distributed. And this is what that takes, right? It's, let's see, 3, 6, 9, 12 or 13 lines of code to get all the specifics we want for this plot, right? Decent amount of work to go into it, but there is a lot of, like I said, customizability. There's so many other additional things that I could do to change up the color scheme of the plot, to continue to mess around with the text sizes, add in grid lines, a lot of things that can be done, but I just didn't feel were needed for that. Next, looking at Seaborn a bit. So pros of Seaborn, if you just create a default plot in Seaborn, it already has a lot of very nice looking formatting associated with it. You really don't have to put in as much of the time and effort to specify a whole bunch of things as you do in matplotlib. It's especially strong for statistical plots. So if you're doing any statistics work, trying to show any data from that, it really does a great job of highlighting the significance of bits of statistical data. Can switch between different font styles and sizes based on the purpose of the plot. So if you're trying to have larger text for a talk or a presentation or for a poster, there's a way that you can just specify, yep, this is for a talk, and then it'll make the text bigger, and you don't have to specify trying to get into the realm of figuring out what the right font size is for your title as opposed to your axis labels. And it's a very straightforward and simple syntax that's pretty easy to get used to. As far as drawbacks, it doesn't contain as much in-depth customizability as matplotlib. There is a lot of customizing you can do in Seaborn, but you aren't able to get as specific as you can in matplotlib. And if you are trying to generate a whole bunch of plots at the same time in a similar way to what I was doing with that GIF back there, Seaborn kind of tends to use up a lot of resources in trying to do that and can create some problems. So some features, like I said, you can easily just, if you have different types of plots that you're trying to get different, show multiple characteristics of the same set of data, you're able to very easily kind of have these joint plots to like I said, just present data in multiple ways while still having it look pretty straightforward. This one is just one line of code. It's just you have your data, awesome. One good thing about Seaborn is that if you're importing a pandas data frame, and we'll talk about that in a later workshop, if you import a pandas data frame, it treats it as one large object as opposed to a series of columns or rows that are independent of each other. So it can automatically start to interpret what your headers are, how your data is configured and stuff like that. Like I said, you can quickly change the style of the figure. If you want to suddenly go from complete white background to kind of a dark grid, it's just one line of code. There you go. Change it up. And then you can see on the right here, you can set the label formats for different figure presentations. So if you're using for a paper, they try to really highlight the data and kind of make the label text a little bit smaller. If you're going for more of a talk, they'll really blow up those label font sizes just so it can be visible from 50 feet away, however size room you're giving a talk for. And then here's a little snippet of so I took the exact same data that I used back here, right? Exact same data set, exact same coordinates, everything. And now just plotted it in Seaborn. There are a few things I'm sure I could have done to have the axis labels actually match, like add in the units for them. But this was just 3 lines of code. Still got to specify the color map, still got to specify all the data, and it just let it all go. So you can see that if you get very invested in either one, they both have their pros and cons with regards to if you put in the time and effort to really get into the nitty-gritty of Matplotlib, you can create some really nice plots. If you are looking for something quick and you're just like, I want something that's gonna, look good and spit some stuff out for a talk, Seaborn is a very efficient way to go. There are a few other data visualization packages that are very widely used. Plotly is very robust and allows for kind of like more interactive plots that can be put into a lot of GUIs, a lot of graphical user interfaces, or in a lot of web pages. For anyone who has a bit of experience using R and is used to plotting using ggplot too, there's a Python equivalent that they've rolled out. And then there's geoplot.lib if you're looking to make maps and plot geospatial data. This is also a good tool that can be used. So I have all these links here to give some reference to the API. I just looked up what API was. It's basically just the functions of how you call the various functions in that package or in that code, and kind of what the different variables mean, what you can specify and whatnot. So that's what the API reference is. For both Matplotlib and Seaborn, some links to specify what their specific color and color map things are, and some examples for both. And then for anyone who's interested in any of the other 3, have some beginning documentation for those. So all that is also in the Google Drive that I shared before and will be sent out in the email from SAG following all of that. Woo! All right. We got a nice solid 15 minutes there. So I guess with all of that, we have about 9-10 minutes to take any questions that folks have about any of the topics that were discussed here, anything past, present, future. Feel free to drop them in that Q&A section and we can Or if not, that's also fine. I know we we tended to cover a lot. Yeah, I hope the pacing of this one was all right. I know biting off a bit much and trying to go from here's how you install Python to okay, now here's data structures and whatnot. But if people have any questions on anything at any point, I think here we go. Eric Davis's question: MATLAB has a very handy see also feature in the help pages, which should discover related functions. This is helpful if you know you want something like zip but aren't aware that it exists. Does Python have something equivalent? Excellent question. That's actually a really good question. No, are you aware?
I don't think it does, but something that you can do is this is something I did a lot when I was going to Python from MATLAB, because I initially during my PhD was using MATLAB for a lot of things, and I started to use Python more. There was plenty of times where I had a function or a thing I wanted to do in MATLAB and I wanted to learn how to do it in Python. And this is a very common question. So if there's, a function that you find in MATLAB that you're like, okay, how do I do this in Python? If you just Google like MATLAB function, whatever Python equivalent, there will be answers on Stack Overflow and stuff sort of pointing you in the right direction. The other way you can find out about functions is if you look in the documentation. So for, the different sort of packages we've talked about, like matplotlib, you can go and look at the matplotlib documentation and sort of look through the list of all the functions that are there. And for some of these, documentation sets, you might be able to like search and do other sort of more advanced things. But no, I don't think there is like a direct thing like sort of see other, at least not that I'm aware about.
Yeah.
Or see similar, whatever the MATLAB function is.
I think I think you're right. I think it's the closest it gets is since you're dealing with a lot of independent third-party packages, Python doesn't really have a great method of bringing those all together and trying to point you in different directions and different packages. But like Noah had mentioned, anytime you're looking at the documentation for any of them, they will have a lot of them, especially some of the more developed and kind of like long time, I guess powerhouses, pandas, NumPy, SciPy, whatever. They'll have a few suggestions of like, oh, here's some functions that are similar to this. So if you happen to find something that's like, oh, here's this cubic interpolator, you're like, I don't want a cubic one, and then like, okay, here's a linear one, and like a little recommended box underneath it. You're like, okay, cool, I can go for that instead. So unfortunately, there is a little bit more searching and clicking around that you have to do to try and find relevant functions. But I guess it's part of the price to pay for the I guess organized chaos of open source. Are there any other lingering questions? All right. I'll say if anyone else has any questions, I'm going to drop my email in the chat if people have